Welcome back to my digital diaries. In today's video from our Frontend Developer course, we will dive into the React series with an essential topic, component-based architecture. If you want to build clean, scalable and professional React applications, this video is for you. Make sure you watch till the end, and if you find it helpful, don't forget to like, share and subscribe to the channel. Let's get started with component-based architecture in React. In this section, we are going to understand the core idea behind React's component-based architecture. This is one of the biggest reasons React is so powerful, scalable and widely used. Now, what is it? So first, what exactly is component-based architecture? It's a design approach where the entire UI is divided into small, reusable and independent pieces called components. Instead of building one big page, we break the UI into mini building blocks, each responsible for a specific part of the functionality or layout. To make this idea easier, think of a Lego blocks. Each block has its own shape, purpose and identity. You build small block first, then you combine them, and finally they come together to form a bigger and more complex structure. React works exactly like this. Now, what makes a component a component? Each component comes with everything it needs to function on its own. It has its own structure, which means it's HTML. It has its own styling, it's CSS, so the design is self-contained. It has its own logic written in JavaScript or TypeScript. And it can even have its own state, meaning it can store and manage its own data. So essentially, every component becomes a small, complete and independent unit. Now let's look at the benefits of this approach. First is organized UI. You get a very organized UI. Everything is clean, structured and easy to understand. Second, your code becomes reusable. Write once and use the component anywhere in your app. Third, maintenance becomes super easy. If something breaks, you fix only one component instead of the entire page. And lastly, components works independently. They don't interfere with each other unless you want them to do. So this makes your application stable and scalable. So the basic idea of a component-based architecture in React: build small components, combine them and create powerful interface, just like building with Lego blocks. Now that we understand the basic idea of component-based architecture, let's look at the key concept that makes React components powerful and efficient. Reusability. The first key concept is a reusability. This simply means that once you create a component, you can use it anywhere in your application. If we take an example, if you design a button component, that same button can be reused on multiple pages without rewriting the code. This saves time, reduces duplicate code and keeps your project consistent. Next is the encapsulation. Each React component is like a self-contained box. It controls everything inside it. That includes its own structure or HTML, its own styling, CSS, its behavior written in JavaScript or even in its state. This separation ensures that changes inside a one component don't accidentally break something outside it. So encapsulation is the second key concept used in components. Separation of a concern. Traditionally, we used to separate files by technology, HTML in one file, CSS in another, and JavaScript somewhere else. React changes this approach. Instead of separating by technology, React separate by features. This means everything related to a single component stays together. Its markup, styling, and logic. It makes the development process cleaner and more intuitive. The fourth concept is composition. In React, larger components are built from smaller ones. It's similar to how you build a page. You start with the small units like buttons and inputs, combine them into a sections, and eventually create full layouts. This building block approach allows complex UI to be built step by step, making applications more modular. And finally, we have a unidirectional data flow. In React, data always flow in one direction, from parent to child. A parent component can send data to its children through properties, props, but the child cannot directly modify the parent state. This one-way flow keeps the application predictable and makes debugging much easier. So, these 5 concepts: reusability, encapsulation, separation of a concern, compositions, and unidirectional data flow forms the foundation of the React's component-based architecture. Understanding this will help you build cleaner, scalable, and more maintainable applications. Now let's walk through the basic folder structure of a standard React application. Understanding this structure is very important because it helps you organize your code properly as your project grows. First is the root folder. At the top we have the root folder, usually named something like my-app. This is the main project folder that contains everything your React application needs. Inside of your root folder, one of the biggest folder you will see is node_modules. React automatically generates this when you install dependencies. It contains all the external libraries your project uses. You never manually edit anything inside this folder. Then you have a public folder. This folder stores static files such as a favicon, images, and most importantly the index.html file. So index.html file is the single HTML file used by your entire React application. React injects your components into a valid div, the ID which you are given, generally it is root, inside this file. And then you have a src folder, the heart of your application. The most important folder is this src folder. This is where all your React code lives. Inside src we typically have components. So the components folder contains all the small reusable UI components like buttons, navigation bar, cars, header, and so on. So these are the building blocks of your UI. Then you have a style sheet and the assets. The asset folder contains images, fonts, icons, or any other static resources used inside your React component, whereas styles contain the CSS or SCSS files. Then you have a pages folder. This is an optional folder if you want to create a screen level component, so you can create this folder. This has a larger screen level component, like if you want to create a home.jsx, about.jsx, or contact.jsx. These pages are built using the smaller components from the components folder. This is optional. If you want to create the major component, the pages like component, then you can go with the pages folder. Then you have a app.jsx and main.jsx. So app.jsx, inside the src folder you will find this, and this is the root component of your application. It usually contains your global layout, navigation, and it loads all your pages, whereas main.jsx is basically your entry point from where your your apps get rendered. Okay, so this is the file that actually render the app component into the DOM using react dom.create root. So main.jsx starts the app and app.jsx builds the layout, and then you have a package.json file and readme file. So package.json file, this file stores your project metadata such as a project name, version, scripts, and most importantly the list of dependency your app requires, whereas your readme file is the file which contains the documentation or instructions related to your project. It's extremely helpful when you are working in terms of publishing your code on GitHub. So overall the structure works like this. So small components are inside the src component. Pages components are built from the small component which is src/pages, and app.js contains all your pages layout, and main.jsx renders your app. So if we summarize, the main.jsx renders, app.jsx loads the pages, pages combines like global layout and pages combines, and it will create your home.jsx, which uses the components. The components can be different: header.jsx, body.jsx, or maybe footer.jsx. So this is the clean separation which help you to keep your project modular, organized, and scalable as it grows. Now let's talk about some of the most important best practices you should follow when organizing files and folders in a React project. Keep a clear and predictable folder structure. First, always maintain a clean and predictable folder structure. Your teammates should be able to open your project and instantly understand where the components, pages are, hooks, and assets are placed. Avoid unnecessary nesting and keep your folder names intuitive. Organize by feature. Instead of separating folders by technology, like one folder for CSS, one for JS, organize by features. For example, if you have a dashboard feature, keep its components, styles, hooks, and tests all inside a one dashboard folder. This makes the code easier to navigate. Keep components small and reusable. The smaller the component, the easier it is to reuse and maintain. Each component should do only one thing. If a component is getting big, break into a smaller component. Use index files for cleaner imports. Create index.js files to export components, pages, or utilities. This helps simplify the imports. Instead of writing a long import path, you can import directly from a folder, making your code more readable. Fifth is a keep asset organized. All your images, icon, fonts, and SVG should be stored inside a well-structured asset folder. Organizing asset prevents a clutter and speed up the development as your app grows. Then keep your styles consistent. No matter what styling approach you use, CSS module or SCS or style components, stay consistent. Choose one pattern and apply it across the entire project. This helps to avoid confusion later. Separate API logic from components. Never mix API calls directly inside your UI components. Create a separate folder like services or maybe API to handle API logic. This keeps your components clean and focus only on UI behavior. Use dedicated folder for custom hooks. We are going to see hooks later in this series. But remember, if your project uses a custom hooks, create a dedicated hooks folder. Custom hooks are meant to encapsulate reusable logic, so keeping them in one place makes them easy to find and reuse. And this you must be knowing it. Use meaningful file names. File names should be describe exactly what the file does. Keep test close to components. Finally, always store the test files next to the components they belongs to. This keeps related logic together and makes debugging faster. If you are using Jest or React testing library, follow the naming convention. These 10 practices will help you to build a React application that are clean, structured and scalable. Let's talk about types of component. In React, we mainly work with the two types of component, functional components and class component. Let's start with the functional component. So functional component are simply JavaScript function that returns React element. They are clean, simple and very easy to read. Since the introduction of hooks, functional components have become the default and most preferred way to build application, whereas the class of component, which are ES6 classes that extend the React.component base class. Before hook exists, the class components were the only way to handle state and lifecycle methods. In this series, we are going to concentrate only on the functional components. So functional components are JavaScript functions. State management is done using hooks, mainly use state, and this allows us to manage states without using classes. We also use hooks like useEffect to handle lifecycle events such as a component load, update or unmount. They offer a concise and modern syntax, much shorter compared to the class component. They are slightly faster and more optimized due to simple structure. And because of all these, functional components are the preferred choice in modern React development, whereas the class components are ES6 classes. Here the state is handled using this.state, which is a bit more verbose and requires binding in some cases. For lifecycle event, the class component uses predefined lifecycle method like component did mount, component did update and so on. The verbose, we have a verbose syntax in the class component compared to the functional component. They are also slightly slower due to more complexity in rendering. And because hooks now provide all the capabilities of class components and more functionalities, class components are less commonly used in modern React projects. And that's the reason our series we are going to work with functional components only. And that's the wrap up our session on component based architecture in the React. I hope this help you clearly understand the evolution of React components and why most developers prefer functional components today. If you found this video useful, don't forget to like, share and subscribe to my digital diaries. See you in the next topic, that will be virtual DOM. Thank you.